Welcome to Let Us Start Educational Channel. In last class we discussed an important law, parallelogram law of vectors. Today we will discuss triangle law of vectors. So what is triangle law of vectors? If two given vectors of same kind are represented both in magnitude and direction by the two adjacent sides of a triangle taken in order, then the closing side taken in the reverse order will give the resultant both in magnitude and direction. So what is given here? Two vectors are given. They have same kind. That means these two vectors are velocity vectors, or these two vectors are force vectors, or these two vectors are accelerated vectors. Whatever it may be the vectors, the two vectors are belongings to the same kind. So they have both in magnitude and direction represented by the two adjacent sides of a triangle. Two vectors వచ్చేసి they represent the two sides of a triangle. Suppose that P bar is a vector, Q bar is a vector. So these two vectors represents the two adjacent sides of a triangle. A triangle has three sides. Here the point is two adjacent sides of a triangle. Two vectors represents the two adjacent sides of a triangle taken in order. They have in same direction. They are in same direction. These two vectors are in the same direction. Then the closing side of the vector, closing side of the triangle. Triangle lo closing side వచ్చేసి third vector. This third vector taken in the reverse order. These two are in the same direction, but the resultant of these two vectors is in the reverse order. That means in this direction, these two are in this direction, but this third vector is closing side of the triangle is reverse to the direction of these two vectors. So the resultant of these two vectors is represented by the closing side of the vector in the reverse order, both in magnitude and direction. So that resultant is r bar. So the resultant vector r bar is P bar plus Q bar. What is triangle of vectors? If two given vectors of same kind, they are velocity vectors, they are force vector, they are position vectors, whatever it may be the vectors. So this vector represents the two adjacent sides of a triangle. A triangle has three sides. Here two vectors represents two adjacent sides of a vectors. What are the two vectors? P bar and Q bar, and they are in the same order. Then the closing side of the triangle in reverse order, in reverse direction, gives the resultant of that two vectors both in magnitude and direction. So according to the triangle of vectors, resultant vector r bar is equal to P bar plus Q bar. Triangle of vector is resultant vector is the addition of remaining two vectors. What is the condition here? These two vectors represent the two sides, adjacent sides of a triangle taken in order. That is the condition. Then the closing side in the reverse order represents both in magnitude and direction. This is the triangle of vectors. What is the resultant vector in triangle of vectors? R bar is equal to P bar plus Q bar. Resultant vector is the addition of remaining two vectors. Next one is law of equilibrium of forces. What is that law? If three forces represent the three sides of a triangle taken in order, then the resultant is 0. If such forces act on a particle simultaneously, then they keep that particle in equilibrium. Three forces are represent three sides of a triangle. A triangle lo three sides untai. Three forces represents three sides of a triangle. So what is the condition here? This is F1, this is F2, this is F3. So these three forces represents the three sides of a triangle in order. That means they are in the same direction. These are all in the same direction. F1, F2, F3. These three forces represents three sides of a triangle and are in the same order. Then the resultant vector is 0. That means resultant vector is F1 bar plus F2 bar plus F3 bar is 0. So three forces represents the three sides of a triangle and they are taken in same order. When they act on a particle, then they keep that particle in equilibrium. If it is moving with some velocity, it continues with that velocity. If the particle moves with some acceleration, that particle moves on with that acceleration. So its motion is going on. Equilibrium means if it's moving with some velocity, this velocity is going on. So this is the law of equilibrium of forces. If they are moving in equilibrium, their resultant vector is 0. This is the simple law. This is the simple law. F1 bar plus F2 bar plus F3 bar is equal to 0. Next one is Lami's theorem. Next one is Lami's theorem. If a body is in equilibrium under the action of three coplanar concurrent forces PQR at angles alpha, beta, gamma, the ratio of each force and sine of angle between the remaining two forces is always constant. If a body is in equilibrium under the action of three coplanar concurrent forces. What do you mean by coplanar concurrent forces? Here the forces are PQR. Body equilibrium position lo ganaka unte eppudu three coplanar concurrent forces. Coplanar concurrent forces means a set of forces acting in a same plane and they have the single origin. Here PQ are three forces. These three forces are intersect at a single point. These three forces are intersect at a single point. So coplanar concurrent forces means a set of forces, they are acting on the same plane. Set of forces, they are acting on the same plane and also intersect at a single point. The three forces వచ్చేసి కోప్లాన్ కాన్కరెంట్ ఫోర్సెస్. అంటే అవి త్రీ ఫోర్సెస్ ఒకే ప్లేన్లో యాక్ట్ అవుతున్నాయి అండ్ ఇంటర్సెక్ట్, అవన్నీ ఒకే చోట కలుస్తాయి అన్నమాట. అటువంటి ఫోర్సెస్ని మనము కోప్లానర్ కాన్కరెంట్ ఫోర్సెస్ అంటాం. సో ఒక ఆబ్జెక్ట్ కనుక ఈక్విలిబ్రియంలో ఉంటే ఈ కోప్లానర్ కాన్కరెంట్ ఫోర్సెస్ వచ్చేసి వాటి యొక్క ఈచ్ ఫోర్స్ రేషియో, సపోజ్ P is a force here, Q is a force here, R is a force here. The ratio of force and sine of angle between the remaining two forces, if P is the force, remaining two forces are Q or the angle between the two forces. So the law is here. These three are originate at a P, Q, R. Three forces. They are all intersect at a single point. So here the force E by, this is the force P. This is the ratio of each force and sine of angle between the remaining two forces. P is the force and the angle between the remaining two forces is alpha. P and sine of angle between the remaining two forces. Sine of angle is alpha here. Next one is the force Q. The force Q and the sine of remaining, the angle between the remaining two vectors. Remaining two vectors are P, R. Angle is beta. Q by sine beta. Next force is R. The R is the ratio of the angle between the remaining two vectors. Here R is the vector, the remaining two vectors is P bar, Q bar, and the angle between these two vectors is gamma. So if a body is in equilibrium, a set of three coplanar concurrent forces PQ are at an angles alpha, beta, gamma as shown in figure. So ratio of each force and sine of angle between the remaining two forces is always constant. This is Lami's theorem. So according to law of Lami's theorem, the ratio of each force and sine of the angle between the remaining two vectors is always constant. That means P by sine alpha is equal to constant. Q by sine alpha is equal to constant. R by sine gamma is equal to constant. So these are some of the important laws. We will do some problems on these concepts in next classes. Your every like is most important for me. Like this channel. If you have any doubts, comment it. Share this channel to others and subscribe this channel for getting more valuable videos.